Hello friends, welcome to Learners Forum. So let us see the next topic regarding the codes and its classifications now. So the first code type is BCD, binary coded decimal. So in general, decimal is represented by a 4-bit binary. This particular code is also called as an 8421 code, which we have seen in our previous videos also. So 8421 represents the value. So on adding that, we can get the required equivalent decimal value. So decimal has 10 values. So 0 to 9. So 0 to 9 is represented here. And the equivalent values of BCD in terms of 8421 are represented here. So let us check it one by one. So first 0, which means all the values of 8421 will be 0. So 4 zeros has been got in the first one. So for 1, we have to take the value of 1 under 1 and all the values under 842 will be 0. So adding all this, we can get the value as 1 in decimal equivalent. Next for 2, under 2 we can write the value as 1 and the other values are taken as 0. Next for 3, 2 plus 1 is 3. So under 2 and 1 we have 1 and the other values are 0. Next for other values like 4, 5, 6, 7, 8, 9. The corresponding BCD values are filled here. For example, if it is 9, 8 plus 1 is 9. So under 8 and 1 we have 1 and the remaining values are 0. So it is 1, 0, 0, 1. Next, to fill the values after 9, from 10 to 15, you cannot represent the value in BCD. So it becomes, don't care, that is, only valid BCD from 0 to 9 is available and the other numbers will be invalid. So to convert a decimal to BCD conversion, let us take an example, 13 to the base 10 now. So now we have to segregate the digits, that is 1 and 3. So 13 is coming under the value invalid. So we have to segregate it as separately 1 and 3 so that we can get the equivalent BCD conversion. So for 1 the value is 0001 and for 3 it is 0011, which is written separately as per the table that we have filled now. So the first value is 0011 for 3 and for 1 it is 0001. So putting together, we can get the value for 13 as 00010011, which represents 13 in decimal. Next, to convert BCD to decimal conversion, a given example is 100110. So starting from the last bit, we have to segregate in terms of 4 bits of each. Since it is a 4-bit binary, so 0110 will be the first set of 4 bit and we have remaining only 2 bits left, which is 10. So for 0110, as per the table, we have got the value as 6 and remaining is just 10, which means we have to fill it in form of 4 digits using 2 zeros which is added in front, which makes the 4 set of bits. So 0010 means the value is 2. So the equivalent decimal value for the given BCD number is 26 to the base 10. So this is how we have to convert a given decimal to BCD or BCD to decimal. Now let us consider binary versus BCD. So given is 14 to the base 10, which is a decimal number. So the difference between converting into its equivalent binary and BCD is, so first for binary conversion 14, which means we can use this 8421 technique. So 8 plus 4 is 12, 12 plus 2 is 14. So under 842 we have binary ones and remaining values are 0. So 1110 we have got it in binary. Whereas in BCD the 14 number is invalid as per the table which we have seen earlier. So we have to write separately for 1 and 4. Then we can get the equivalent BCD value. So for 1 it is 0001 and for 4 it is 0100, which is the equivalent BCD for the given decimal number. So as you can see, this BCD number has more number of bits. So in binary we have just 4 bits, but in BCD we have got around 8 bits. So more bits are available, which makes less efficient than the binary. And since we have got more number of bits, in case if we are performing any binary operations, then it will be difficult. This is the disadvantage of BCD when comparing it with binary. Next, consider for BCD addition. So here we have three different cases. If the sum value is less than or equal to 9 and carry is equal to 0, then there is no change. Like we can just perform the normal addition operation. And in case if the sum is less than or equal to 9 and carry is equal to 1, then we have to add 6, that is the value of 0110 to the value. Next, for sum greater than 9 and carry is equal to 0, again we have to add 6, that is 0110. So for these condition we have to add the value as plus 6. BCD is actually 4 bits, that is 4 in the sense 2 power 4, which is equal to 16. So 16 in the sense we should have got the values from 0 to 15. But from 0 to 9 we have got the valid BCD. So the remaining digits, that is 15, which is the total bits, and the last one is 9. So 15 minus 9 will be 6. So that is the reason we are adding this 6 to make it as total number of 16 values. So this is the reason we are adding it over here when we have the last two cases. So these are the steps that we should remember to perform BCD addition. Now let us solve an example. Given is 3 plus 4, which are decimal numbers. So first we have to write the equivalent decimal value, that is BCD value, for the different things. So using 8421 technique, we have to represent the value of 3. So under 211 we will have 1 and the remaining value as 0. So for 4, under 4 we will have binary 1, remaining 0. So these are the values for 3 and 4. Now we have to perform addition. 1 plus 0, 0, 1 plus 0, 0, 1 and 0. So 0 triple 1 will be the answer. So 0 triple 1 means the sum value has to be checked. So 4 plus 2 is 6, 6 plus 1 is 7, which is less than 9. And we don't have any carry, so carry is 0 here. So this represents the first case, sum value is less than 9 and carry is 0. So there is no change over here and we can leave it as such. So adding this we will get 3 plus 4 is equal to 7. So this is our first case example. Now let us solve few more examples. Next let us solve one more example, 3 plus 9. So to represent 3 and 9 in 8421, 2 plus 1 is 3. So it will be 0011. Next for 9 it is 8 plus 1, so 1, 0, 0, 1. Now let us perform addition. So starting from the last bit, 1 plus 1 is 0, 1, carry, again 1 plus 1, so 0, 1. So 0, 0, 1, 0 plus 1 is 1. So now we have carry 0 and 1, 1, 0, 0 in the sense 8 plus 4 is 12. So we have got the value as 12, which is greater than 9 and carry is 0, which represents the second case. So whenever the value is greater than 9 and when the carry is 0, we have to add the value 6 to the last one. So the value of 12 is belonging to the invalid code. That is why we are adding this 6, which is 0110, 0 plus 0, 0, 1, 0, carry 1, so 0 and carry 1. Now we have got the carry value 1 and the value is 0010. So 0010 will represent the value as 2 and 1 is 000. So we have now got the value in terms of BCD. So 1 and the corresponding decimal equivalent is 12. So now we have got the actual answer 1, 2, which is expressed in BCD. So this is the reason why we are adding 6 to the last digit whenever the case 2 is satisfied. If not, we will get the value as 12, which will belong to the invalid code. Now let us solve one more example, which is 62 plus 29. So for 62, we have to represent 6 and 2 in 8421 separately. So for 6 it is 4 plus 2, so 0, 1, 1, 0. For 2 it is 0, 0, 1, 0. Next for 2 it is 0, 0, 1, 0. For 9 it is 1, 0, 0, 1. Now we have to perform addition starting from the last bit. So 1, 1, 0, 1, 0, carry 1, so 0, again 1. Now Let us check the value. 1011 means 8 plus 2 is 10, 10 plus 1 is 11, which is greater than 9. Here it is 8, which is less than 9. So for the first 4 bits, we need not do anything. But for the second half, we have to use our case as we have seen in the first topic. So we have to add the value of 6, which is 0110 to the last 4 bits. So 1000 and carry 1, which has to be taken here. So 1001 0001. So these 4 bits separately represent the value 9 and 1. So now let us add and see. 9 plus 2 is 11, 6 plus 2 is 8, 9. So 91. Here it is represented in BCD. So this is how we have to perform BCD addition.